All right, we're recording. 4.2, theoretical probability. So before we calculated probability based on samples or trials, but there's another type of probability calculation, Jasmine, theoretical probability. It's the event that an will occur based on the number of possible occurrences rather than the total number of items or events in a trial. For example, if you toss a coin, there's two possible outcomes, heads or tails. The theoretical probability of landing on heads is 50%. I think you know that 1 out of 2, right? Now, in the previous section though, if you had flipped a coin 30 times or whatever, the answer might not have been 50%. It probably wouldn't be actually, because it would land on one more than the other. Theoretical and experimental probability may differ if the experimental sample size is smaller. However, in a large sample, the experimental probability is pretty close to the theoretical. So, let's go through this here. Are you familiar with cards, Jasmine? Nope. Okay, here's what you need to know. 52 cards in a deck. Now, I'm going to be recording those. Oh, there's 52 cards in a deck. You're aware of the suits, clubs, hearts, spades, diamonds, right? And in each, ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. Are you aware of those things? Okay, so there's 13 of each. There's 13 ace through king hearts, 13 diamonds, 13 clubs, 13 spades. So that's really what you need to know. And if you ever need some advice, if you're doing a problem about how many hearts or whatever it is there, I can remind you stuff. So, if there's 4 different types of suits, we call it hearts, clubs, diamonds, spades, what's the probability that one of the following cards will be a heart if you just drew one off the deck? 13 out of 52. So, there's 2 ways of thinking about this that way. So I'm going to just put probability of a heart. That's next. Now, actually, honestly, if you're sharp at these things, you can actually, sometimes some gambling games could be in your favor. Now, you can divide top and bottom by 13. 13 divided by 13 is 1. 52 divided by 13, you do this and you'll probably only have to do it once. 4. And think of it this way. Remember how you could have jumped right to 1/4 by saying, oh yeah, there's only 4 types. There's hearts, spades, clubs, or diamonds. One out of 4 cards is in the heart suit. You could have. Most people do it the way you did, so highly recommend. A black jack. Now, here's what you don't know. Of the 50% of the cards are black, 50% are red. The spades are the blacks, and the clubs are the blacks, the hearts and the diamonds are the reds. But let's put it this way. Jacks, half of the jacks are red. Okay? So how many, do you follow what I'm saying? There's 2 red jacks, or 2 black jacks, I guess it is. So, the probability of a black jack is, there's 2 black jacks out of the 52 cards. If you cut that in half, that's 26 out of 26. Now, like I say, these are tricky if you're not familiar with cards, and I'll help you out. A card other than a diamond. There's 2 ways of thinking about it. There's 13 diamonds in the deck of 52, so everything else is not diamonds. 52 subtract 13, which is 39 out of 52. You can divide by 13, and trust me, you'll get 3/4. How could you have jumped to that one? Well, you could have said, I know that there is red hearts, diamonds, and I know that there is I can't draw the clubs very good. Actually, not bad. And then the spades. Okay. Does it make sense that since you don't want a diamond, 3 out of 4 cards aren't diamonds? You could have jumped into that way too. If you were more familiar with cards, you probably would have thought of it that way. Now, what about these? Example 2. What's the probability? Now, 6-sided die, I'm sure you're familiar with this. Rolling doubles. I hope you know how dice work. Okay, good. So let's just think this through. I'm going to show you with a little diagram here, maybe. You know, with the first die, you could get a 1, 2, 3, 4, 5, or a 6, right? The second die, then, if you got a 1 on the first one, you could get a 1, 2, 3, 4, 5, or a 6 with the second one, right? Now, it's going to run out of space over it. With the first die, you can get a 2, and then a 1, 2, I think you see what I'm doing, right? 4, 5, or 6. You could get a 3, and then a 1, 2, 3, 4, 5, 6. 4, and a 1, 2. Run out of space, so I'm going to put the 5 here. And a 6. Those are all the different ways you can roll 2 die. Does that make sense what I just wrote out? Every possible combination? How many combinations are there then? I guess I should say permutations, not that we're worried about the first die and the second die. You could get, though, look at this. There's 6 ways you could roll the first die times 6 ways you could roll the second die. There's 36 different ways of everything. How many are doubles? How many different doubles? Well, there's a double for 1, there's a double for 2, there's a double for 3, there's a double for 4, for 5, and for 6. There's 6 doubles possible with 1s, with 2s, with 3s. So, what is the probability, Jasmine? 6 out of 36. And you can reduce that fraction. What's that game? Snakes and Ladders? Is that where you roll doubles and you go backwards? Nope. Even better. 6 divided by 6 is 1. 36 divided by 6 is 6. 1 in 6 chances of rolling a double. Now here's like a trick question. This is where gamblers get confused. They waste a lot of money. Adele's playing a board game, B here. If she rolls doubles on her first turn, what's the probability that she'll roll doubles on her second turn? Here's a question I'm going to ask you. Do the dice have memory? Do they know you rolled doubles the first time? No. So what is the chance? Still 1 in 6. What people are getting confused is, if I started out before I ever touched the dice the first time, if I say, what's the chance of me rolling doubles 2 times in a row? Now that's different, but it's like having a baby too, flipping a coin, 50-50, boy or girl, right? My wife's uterus didn't remember that it had a boy or girl the first time and that it was a boy the second time, and if you know what I mean, if we were expecting, it'd still be 50-50 for the next child, right? I guess I'm using pregnancy examples. Anyways. But actually, I do whether anyone's pregnant or not, because having babies is 50-50 too, gender. Okay, last example here. Louise is playing a card game. She draws 1 card from 52 cards, a standard deck. Without replacing the card, she draws a second. Now, how many aces in the deck? So what's the probability of drawing an ace? There's 4 aces. Probability of an ace is 4 out of 52. Everything reduces to out of 13 if you're talking like that. That's divide by 4, it's 1 out of 13. But here's the next one. If the second card if the first card chosen is an ace, what's the probability that the second card is a 2? So this is a different question. This is where of a 2 second draw. Okay. Well, how many number 2s are in the deck? 4. How many cards are left in the deck after she's already won 1? 51. 4 out of 51. That doesn't reduce. It's just 4 out of 51. Now, is there any questions there? I think I'm going to stop the recording because that does it.